The next DAX function that I want to talk about is all. Now the all function either returns all of the rows in a table or all of the values in a column, completely ignoring any filter context. So here's what it looks like. Your first argument of the function is either the table name or the column name that you want to clear filters on. So you could point to the entire sales or transactions table here, or a specific column like product category from your products table. And keep in mind here that all does not return a single number. It returns a table or a subset of a table. So you'll almost never use all by itself. Instead, you'll use it as a component of other functions, most commonly calculate. Now, the second optional set of parameters or arguments here are column names. So if you've selected a column in your first argument as opposed to a table, you do have the option to list additional columns here that you'd like to clear filters on. The catch is that all of these columns must be fully qualified and include the table name, and they must all come from the same table. So, pro tip, instead of adding filter context or changing it like calculate does, all removes it. And that sounds a little confusing and counterintuitive at first until you realize what it's commonly used for, which is when you need unfiltered values that you don't want to react to changes in filter context. Great example, which we're going to practice, is a percent of total calculation, where your denominator, your grand total, needs to always remain fixed. So let's head to Power BI and give this a shot. All right, here in my report view, I want to practice adding two new measures using that all function. But again, we're not going to use all on its own. We're going to use it as part of a calculate function. And the first one that I think we should add is a measure to capture the grand total orders, or all orders across the board. That way we can take our existing measure, the total orders measure, and take a ratio to calculate something like the percent of grand total. So let me show you what I mean by that. This is going to be assigned to our sales table, since this is a sales related metric. I'm going to add a new measure, and let's name this all orders. I'm going to make all kind of all caps just so that it sticks out and reminds us that we're using the all function as part of this measure. And so the way that we're going to calculate all orders, which is essentially the grand total of orders, is to start with our calculate. We're going to calculate our existing total orders measure. So here's where things get a little bit strange, because the calculate is now asking for the filter argument in our function. So this is where we would normally add filter context, like country equals USA, or quantity is greater than 1. Instead, in this particular case, we want to strip filters out. And anytime you want to remove filters, you know you need to use the all function. So we're going to type the all right here in the filter argument of our calculate. And we're going to just input the table name of our sales table, because the sales table contains the order information that we're using to calculate our total orders measure. So we can just type AW underscore sales and we'll get the entire table. This icon looks a little bit different because it's the whole table, not an individual column. Tab it in, close the parenthesis, and then close one more parenthesis at the end. So to recap, give me the total orders calculation applied to the entire AW sales table, no matter what. So let's press enter, lock that in. And there we go, it's added it into our AW sales table. And now what if we just select our matrix here and grab all orders and drag that into values. So check this out. We've got our total orders column, which is the measure that we're calculating. Now this all measure that we just created, this all orders measure, even in rows where the filter contexts are trying to tell it to filter down to different categories, accessories, bikes, clothing, the all statement that we added in the filter argument of our calculate is saying ignore all that and just return the grand total no matter what, no matter how this view, this matrix, this report page changes. So this field alone is not that helpful. As you can see, there's no real circumstance where we'd want to drag this field in or analyze it by itself, but where it does become useful is serving as an input for something like percent of all orders. So let's go ahead and add another measure, new measure, and let's call it actually, just like I said, percent of all orders. And what we're going to do here is basically just calculate the ratio of our original total orders measure divided by that brand new all orders measure. So that denominator, which is defined by the all function in the calculate, will never change. It's always the grand total. But the numerator, total orders, can change in reaction to different filter contexts, as you can see right here. So when we go ahead and lock that in, drag it into our matrix visual, we can go ahead and enter the modeling tab to format it as a percentage. And look at this, it totals to 100%, which is correct. And now we can see really interesting insight, like what percentage of the total orders do accessories account for? In this case, about 2/3. What about bikes? Just over half. Clothing, about 28%. Now a little added bonus to this, even though all orders is a component of this percent of all orders calculation, it's the denominator, it does not need to live here in the matrix for us to calculate our percent of total. So let's remove that, and there you go. It still functions exactly like you'd expect, and it can still be filtered and segmented in any way you can imagine. So that's a great, very common example of how to combine calculate and all to create these percent of total fields. Now, one more quick demo here. I'd like to add one more measure, this time to our product lookup table. So I'm going to right click, add a measure within product lookup. And for this one, I'd like to calculate the average retail price or the average product price across the entire table, which will essentially give me a single number that captures the average price across the entire product set. So let's name this overall average price, okay? And remember, we've already calculated an average retail price just using that basic average function on its own. So now what we can do is calculate that measure, average retail price. And since we don't want our overall average price to change in reaction to filter context, we always want the same overall average number to be returned. That means we need the all statement here again. And this time, the table that we're going to reference is not the sales table, it's not the returns table, it's the AW product lookup table right here. Close out two parentheses, and to recap, we're evaluating our original average retail price, which is the average of the product price column values, and we're evaluating it based on the entire AW product lookup table every single time. Press enter to lock it in. And now to see how that's working, we can go back to our matrix here. We've got our original average retail price, which we'll pull in. And then we've got our overall average retail price, which we can pull in second. And there you go. You can see that our overall average, which used the all function, gives us that same total average, that same overall average every single time. So while we're here, let's go ahead and make that currency $English. And there you go. So now we can see interesting things like the average price for accessories is well below the average. Bikes is clearly pulling the average up. Clothing average is about $51. Components $432. And when you blend all of that together, the overall average is about $714. So we're going to be using this overall average price measure as a way to demo another function that's commonly nested with calculate, which is called the filter function. So stay tuned, that one's coming up next.